Hello, Gauntlet. This is Darius Arana, and I'm going to go over the audit, the user workflow, and the architecture. So, starting off with the audit, um, when I conducted the audit, I found that OpenEMR's system is a mix of legacy code and modern APIs. This naturally poses a risk since any system is only as strong as its weakest link. And generally speaking, legacy code tends to have more vulnerabilities. The first security issue that I noticed was the access control. Um, so there were places in the code where the authorization checks can be too permissive in certain edge cases. If that isn't taken care of, then patient data could be seen more broadly than intended. And not only could that violate patient privacy, but it could also put hospitals at legal risk. Another issue is logging and PHI exposure. The system has good logging capability, but in some configurations, logs can capture too much sensitive detail. So the risk here is that even if core systems are secure, sensitive information can leak through operational logs, and this is both a compliance and patient privacy risk. Next up, there is an issue where the performance of OpenEMR by itself could potentially slow down. So there are places where there are heavy report paths, inefficient query patterns, and synchronous bottlenecks. This could potentially slow down the agent response time, and that kind of goes against the purpose of the agent because the agent is supposed to provide doctors important information quickly, and if that gets delayed, then doctors would stop trusting the agent and not use it at all. And let's see. The other concern is data quality. Some domains have strong validation, but consistency controls are uneven across the system. For a physician, that can mean acting on incomplete context, and for a patient, that could mean delayed or missed follow-up. And the final issue was the compliance readiness. The audit shows strong building blocks, but uneven policy enforcement around retention, disposal, and incident workflow. The risk is operational confusion during high pressure events. And that's it for the audit. Now we'll go on to the users.md. Okay. So for the target user, I decided that it should be a family medicine doctor who has to see a lot of patients, usually 20 or more per day. The reason I chose this as a target user is because, well, first of all, the use case that was provided in the Agent Forge document was for like a generic doctor, and I wanted to kind of niche down on a specific doctor. And as a patient myself, I have the most experience, interacting with family medicine doctors. So I feel like, if I could make an agent for any kind of doctor, it would be more beneficial for family medicine practitioners because I have a slightly better understanding of, how they work compared to other kinds of doctors. So this agent will have three major use cases. The first one being pre-visit briefing. So the basic idea is that when the physician has to quickly move on to the next patient, in that 90-second time frame, when they open the app or when they open EMR in their tablet or laptop, they should see like a quick summary of who the patient is, what their primary concern is, lab reports, nurse notes, and etc. And yeah, and the second use case would be a basic QA assistant during the actual appointment. If the doctor, like during the appointment, if the patient, for example, asks the doctor, "Hey, what prescription did you put me on, a few months ago?" The idea is that the doctor could directly ask that question to the agent, and the agent would retrieve that information properly from the OpenEMR database. Um, Second. And yeah, the third use case would be critical flag surfacing. So the assistant should proactively highlight things like interaction risks, unresolved abnormal labs, and overdue care. If this isn't taken care of, then the risk is delayed recognition of important follow-up items. Um, so when I was designing the key use cases for this app, um, I wanted to make sure that the assistant is there to, retrieve data and not make treatment decisions. That's a doctor's job. And this is risky because if that boundary kind of, blurs, um, the doctor could potentially over rely on the agent itself, which is not a good thing because, down the line it could lead to, improper diagnosis, you know, patients getting improper care, uh, and then, after all that, the hospital and the doctor facing legal consequences. So, yeah, the assistant is just there to surface the data or to like read the data, not to like make treatment decisions. Okay, last but not least, I'm going to go over the architecture. Okay, let's see. Right, so for the architecture, um, give me 1 second. Little sick here. Okay, okay. Yeah, so my first major design decision was to embed the agent directly into OpenEMR. That way, it reduces context switching and it just makes the user interface simpler, right? I don't necessarily want a completely different screen that the doctors have to switch between, especially when they're moving quickly from patient to patient. But the trade-off is that when we implement this, it'll be a tighter. It'll basically um, we'll have to make some direct changes to the OpenEMR code that deals with the UI, and this can make long-term changes more complex. So that's something to keep in mind. The second design decision I made was to run the AI orchestration in a separate service. So here you can see that I have the plan is to deploy everything in 6 containers. If you the when I tried deploying the OpenEMR application locally, I noticed there were about 5 containers, and because we're going to be adding an agentic layer to this, that AI agent will be in a separate container. Reason being is that um, it'll improve the speed of the response time. But the trade-off, of course, is that because we have an extra container, we will need to have more infrastructure to secure, monitor, and maintain. Also, for whoever maintains this application, if for some reason they're understaffed or undertrained, then the reliability risk goes up. Okay, and let me go over my other decisions. Okay, so the third major decision was to retrieve data through the structured open EMR paths. So initially, I wanted to implement my own. So when I talk about open EMR paths, what I really mean is like direct queries to the open EMR database. Excuse me. Um, However, that isn't necessary because OpenEMR does provide their own, paths or their own functions to interact with their database. So that improves the consistency and maintainability of the app. Um, I don't believe there's a trade-off to this. I think it's just better to stick with, um, you know, what the Lexi code includes. And the other decision I made was to enforce verification around the excuse me LLM output. That improves grounding and reduces hallucination risk. But the trade-off is, extra pipeline complexity and possible latency overhead. If this isn't managed well, then the user experience could suffer. And finally, um, uh, because the Agent Forge project description emphasizes this, we want to keep strict guardrails. So stuff like read-only behavior, scoped access, auditable traces, and data-only output. Um, Reason for this is because although speed matters, when it comes to healthcare, accuracy is far more important. Um, the only trade-off to having strict guardrails is that it's less convenient for automation purposes. Um, but like I believe that safety matters more than anything. So yeah, that's my demo for yeah the basic architecture